So yes, today we're going to talk about nitrogen generator applications in breweries and wineries. It's an area we've been involved with for some years now, and we're finding that we're getting an increasing number of inquiries from this market sector, and it's somewhere where we can really be successful. Now, in the US, there are 11,000 wineries or more operating today. Over the past 60 years, there's been an explosion in the number of US winemaking businesses. This map shows you the number of wineries that was existing in 1963. You can see the highest concentration is in California and a small number in the northeastern states. Now, that grew in 1998, you can see significant investment has gone on in 1988, still dominated by California and up on the Northeast coast, but with some expansion up on the Pacific Northwest too. And today, here you can see the 11,000 plus wineries that are in the market today. And you can see virtually every state in the US has a wine producer now. So this market is growing, it's growing quickly, and it offers us great potential for nitrogen generators right across all of the US. Now, beer is the most widely consumed alcoholic beverage in the world. It's the third most popular beverage after tea and water. And in the US, there are over 9,700 US breweries operating today. In the past 20 years, there's been significant growth in this industry. Much smaller breweries have been starting up. All these breweries use filtration, as we well know, for liquids and gases, but there are also good opportunities for us in nitrogen generators. And we're going to outline some of those today. Now, the US beer industry is absolutely dominated by a small number of companies. I'm sure you recognize some of the names here and the large beverage brands that they produce. These beers are produced in enormous volumes. And while there are some opportunities with such enormous organizations, in our experience, when it comes to nitrogen generators, the section that you see in green called the All Others section, that's where most of the opportunities for us sit these days. Let me get in that section, we have smaller craft brewers. Now, these organizations tend to be smaller, more entrepreneurial companies, sometimes employee-owned, operating in a very small geographic territory, and they're a great target and a great customer base for us to promote nitrogen to. Now, inert gases are critical in the manufacturing of both these beverages, of winemaking and beer processes. They are used in multiple areas. Their primary use, as you may be aware of in other applications, is just to protect the product from the effects of oxygen. Oxidation, increased biological spoilage is also an issue. And in winemaking, limiting the oxygen level in contact with the wine at various stages actually helps protect and preserve grapes' natural antioxidants and the aromas and the colors that are so important in winemaking. Now, both beer and wine, they do share some similar processes that we'll talk about. They take raw ingredients, they go through a number of stages to produce the final beverage. And nitrogen gas can be used in a number of these processes. So we're going to outline a few of those today, and we can show you where you can help a customer with their gas supply. Now, the winemaking process is actually very straightforward. There are just 6 steps. Grapes are grown and harvested, and the first thing that they do is they are crushed and destemmed, and this separates out the juice from the flesh of the grape. It's then put into storage tanks, and fermentation takes place. Now, that fermentation is developing the alcohol. Now, various other steps go. Wine is crushed and filtered and allowed to mature for a while in casks before it's bottled and shipped to my house a lot of the time. And the opportunities for nitrogen in the winemaking process start immediately after the harvesting of the grapes. So let's look at some of those. At the very beginning of the winemaking process, grapes are pressed or crushed to release the juice from the skins and the flesh. Now, modern presses like these at a customer that I visited in New Zealand are actually purged with nitrogen at the very outset. So even during the pressing stage, the grapes are blanketed with nitrogen to eliminate oxygen to preserve the quality of those grapes right at the very start. Now, not all presses do this. Some presses are very mechanical and are just done under atmospheric conditions, but you may come across wine presses that use nitrogen. So it's worth asking when you visit a customer in the wine industry, talk about the press or the crush and see if that's done under nitrogen, because that's something that does happen in some wineries. Now, you'll find large stainless steel tanks across the winery, and they're used at various stages of wine production and beer production. These tanks are usually purged with CO2 or nitrogen, and that displaces the oxygen before the tank is filled with the liquid, before the wine or the beer goes in. Now, after the tanks are filled, often inert gas is fed onto the top of the liquid to purge out any oxygen, to form a blanket on top of the wine to protect the quality of that product inside there. And depending on the size of the winery, you might find many tanks or just a few tanks. And it can sometimes be a little bit intimidating when you visit a winery and you see 40 tanks of various sizes. To try and convert that into a nitrogen flow rate can sometimes be a bit intimidating, but I'll show you a couple of examples that we use. And it's a very straightforward process to come up with a good estimate on how much nitrogen is needed. So the first one, let's take, for example, a 5,000 gallon tank, and it's partially filled with wine or beer. And let's assume that 5,000 gallon tank is, 4/5 full, it's 80% full. So there's 1,000 gallons of head space in the top of that tank. So that's just air, empty volume on top of the liquid. All we need to do here is convert that volume to cubic feet. So if it's 1,000 gallons, that's 133 cubic feet. Now, when you visit a winery, it's very typical for them, if they're using CO2, they'll wheel in a dewar of CO2. They will feed it into the tank headspace at the top, and then they'll move along to the next one. And they'll do that, every other day. So they might do it Monday, Wednesday, Friday, and they'll just replace the volume that's in there. A good a good calculation is just to take that 133 cubic feet. You know that they do it every 3 days, or every 48 hours rather. 48 hours, 133 cubic feet. That one tank is going to use about 2.8 cubic feet an hour of continuous nitrogen. Now, it will be an intermittent purge. It will be a constant purge on the nitrogen. It's not like wheeling in a dewar, filling the tank and then going away. This is just a constant purge of nitrogen. So what it also does is it removes that manual input. The winemaker doesn't need to go from tank to tank. You just put the generator in there, feed the gas in, you've got nitrogen on tap. The working pattern is important to the customer though. So find out if they are doing the Monday, Wednesday, Friday thing. Most customers will know what their regular routine is, and they also will usually know exactly how much wine is in a tank. It's a good way of estimating a nitrogen flow rate. Another useful thing to understand is pump out rate. When wine is pumped out of a tank, nitrogen is usually fed in at the same rate that the liquid is pumped out. They do that to make sure that the tank doesn't collapse in on itself. You do find pump flow rates will vary, so that's worth checking. Find the pump, have a look at the rating plate, see what it's rated at. But you will come across 25 gallon and 100 gallon per minute pumps regularly at wineries. So check that out. And again, the working pattern's important. But here you can see a 25 gallon per minute pump, convert that to cubic feet, and you can see we've got between 200 SCFH and 800 SCFH. It's a very straightforward calculation. The wine's taken out at one volume, nitrogen goes in at exactly the same volume. You might find the pump attached to the bottom of the tank permanently, especially in some of the larger wineries, but you also will come across mobile units where a pump will be on a trolley and it will be wheeled from tank to tank. That's something worth discussing with a customer too. They'll just move the pump, hook it up to an air line or a nitrogen line, and then they'll do their pumping. Now, in cases where nitrogen gas is used to push the liquid from one place to another, that process is called pressure transfer. So nitrogen at low pressure is fed into the top of the tank, and it actually forces the wine or the beer out of a port at the bottom of the tank, pressure transfer. Now, in this case, the customer could ask or could let you know how big is the tank and what is the typical time that you want to empty that tank. So if it's a 5,000 gallon tank that we referred to earlier, and your customer wants to empty that in 1 hour, 5,000 gallons an hour, convert that to cubic feet, and we're looking at almost 670 cubic feet an hour. That's a really easy conversation to have with the customer. How big is your tank? How long does it typically take to empty it? Then if they've got multiple tanks to be emptied at the same time, then you'd need to take that into consideration too. If they're doing 5 tanks or if they're doing 1 at a time, that's an important thing, obviously. You would have to multiply that up. But that's a good, easy conversation to have with a customer, and they'll know this detail. They know the operation of their winery inside out. They'll know this. They'll be able to help you with that. Now, another process that's used in wineries is sparging. And sparging is introducing very small, tiny nitrogen gas bubbles into the wine at the base of a tank. There are various designs that are available. The one pictured here that you see is a simple stainless steel sintered rod. It's threaded on one end so you can screw it into a port in the side of the tank. Some tanks have fixed sparges in them, in a ring formation at the bottom. Sometimes you may come across a submergible wand, and a customer will just go from tank to tank. They'll sparge the tank, they'll take the sparging rod out, and they'll go along to the next tank. So that's worth asking a customer how they're doing their sparging. You sometimes also find inline spargers. So in the pipe between the tank and the next process, you'll find an inline sparger where nitrogen is fed in. And here's a good example of a possible tank design. And you can see the sparging rods in the bottom. They go right around the entire diameter of the tank. Nitrogen is fed in from the side of those ports, and they just bubble up through the surface of the wine. Now, in this sparging process, gas is flowing up through the wine, and the bubbles, as they pass through the wine, they actually pull out any dissolved oxygen that is in the wine. The sparging time does vary. It tends to be around a minute, sometimes up to 10 minutes, depending on the size of the tank, and can also depend on the kind of wine that is in the tank. You'll often find an oxygen meter, which is used at the top of the tank to monitor the level of the oxygen coming off. And once a certain level is reached, they'll have a target in mind. Once that level is reached, they stop sparging, they move on to the next tank. The machine here that you can see, it's a little mobile sparging unit, and it feeds nitrogen into the base of the tanks. It's actually linked to the oxygen analyzer at the top of the tank. Once it's complete, once it reaches that level, the unit's wheeled on to the next tank and they move on. The nitrogen dosage rate, the amount of nitrogen that is fed into a tank, does vary, but another good rule of thumb, between 1.3 and 3 cubic feet of nitrogen per 100 gallons of wine. I mean, we've learned that over the years is a good estimate for the amount of nitrogen that needs to go in the tank. It's also worth checking if there's a gas flow spec. If a customer has a manufacturer of a sparger there, sometimes you can get a data sheet on that sparger, find out how many are in the tank, and a customer would be able to tell you, yeah, it's using X cubic feet a minute. I often find that winery operators are really knowledgeable in this. They know what they're talking about. They've been doing it for many years. So often when you're talking about sparging, the nitrogen usage, a customer pretty much knows what they're doing. Now, this chart shows the results of some trials on sparging with CO2, nitrogen from a nitrogen generator, and argon to evaluate how effective they are at sparging wine to bring the level of dissolved oxygen down. And looking at that main chart, you can see the nitrogen and the argon, the blue and the orange line there. They bring the dissolved oxygen level down much faster than the CO2. The CO2 seems to take almost 2 times as long to get down to the desired level. The level that they were looking at in this case was at about 6 hectopascals. It was a partial pressure of oxygen. A bit too much detail there, but you can see the charts. The chart clearly shows that argon and nitrogen are much faster at bringing that dissolved level down than CO2. So nitrogen and argon do a similar job, but nitrogen has the big advantage of argon in that nitrogen can be made on site. Argon has to be bought and it's expensive. The smaller chart at the top there shows another plot that we did, and it was plotting the volume of the wine and the volume of the gas to see how effective the gas was, not just in terms of time, but in terms of volume. And you can see that the volume of CO2, the red bar on the right, the volume of CO2 needed was much higher than the nitrogen and the argon. So this is another good reason that nitrogen for this particular application is the best gas. You can make it yourself, it's cheap, and it's faster, and it uses less gas. And this is real world testing at a winery. You might also come across an additional step that some wineries do, where they will actually flush hoses that are used to connect the wine or beer for transfer. They'll actually flush those hoses before they start the filling, because obviously when it's first starting and those hoses are empty, they've got air in them. So that's an additional step. It uses more gas, but doing that helps eliminate further contact with oxygen at that stage of the process. So that's worth checking with the customer too. Do you purge your hoses? How long are they? How long do you purge them for? If you know it's 100 yards long and it's a certain diameter hose and they purge for 10 minutes, that's a good way for evaluating and calculating a nitrogen flow. Another process in the winery you'll come across is called racking. Now, racking is the process of moving wine from the barrels where they're aged to other tanks for storing or for filtration or for processing or for stabilization. And you'll find a common method is using what's called a bulldog pump. And this is a racking one that uses nitrogen pressure to pump wine out of wine barrels. And you can see one in this photo here. And this one uses nitrogen pressure at about 15 psi. And it will empty a nitrogen barrel in about 3 or 4 minutes. A typical barrel is around 60 gallons. It'll empty that in 3 or 4 minutes. You can see the clear window at the top of the bulldog pump. It's full of red wine. And you just do that. You keep an eye on it. When that starts to drop, when the level in there starts to drop, you know you're emptying the barrel and it's done and the nitrogen is turned off. It's a really effective way of emptying wine barrels, but there are 2 important things here. One is for minimum agitation. There's sediment in the wine when it settles in a barrel. You don't want to disturb that sediment. So using nitrogen to gently push the wine out prevents that sediment being picked up. It's a much more gentle transfer of wine, is the way I would describe it. And the second thing, the obvious thing, is using nitrogen just prevents any oxygen getting in touch with that wine. No oxidation protects that wine from the contact of oxygen. Now, nitrogen for these particular pumps, around 70 to 80 SCFH. So ask a customer if they're using a bulldog pump in a wineries, the chances are they are. But if they're using another similar kind of pump, just find out what the spec is. You can easily work out a complete nitrogen flow for that. But 70 to 80 SCFH is a good estimate. Now, wine is particularly prone to excess oxygen exposure when it's bottling. The turbulence of pumping that wine, sometimes mixed with air, depending on the kind of pump. Sometimes there's air in the hoses too, and the bottle filling machine. So the process of bottling is a particular hotspot for oxygenation of the wine. So to prevent this, a lot of bottle filling machines use nitrogen. Nitrogen is flushed into the bottles to prevent oxidation. Now, the way that these things work, the empty bottles come in on an automatic line. They are flipped, they are turned after filling with water, they're turned upside down, and then either compressed air or nitrogen is flushed in to dry the nitrogen of the bottles. Now, depending on the machine type, nitrogen might be used at that first stage, or nitrogen might only be used to fill the headspace between the top of the liquid and the closure, the cork or the screw top that's put on. Usually the bottle will be flushed 2 or 3 times, depending on the particular machine design. But that's worth asking about. Is it a 2 flush or is it a 3 flush machine? Now, there are a lot of machine manufacturers, and each will have their own nitrogen specification, but a very good rule of thumb is to use 4 SCFH of nitrogen per bottle per minute. So find out what the bottling line is running at. In wineries, it's very common to come across a 60 bottle a minute, 100 bottle per minute bottle filling line. You come across them a lot. And as you can see, 60 bottles per minute times 4, 240 SCFH. So that part of the plant will use 240 SCFH. Or if it's running at 100 BPM, it's around 400 SCFH. So ask the customer, how fast is your bottling line? The bigger wineries that you come across, I've seen systems running at 500 bottles a minute too. But the same rule of thumb, 4 cubic feet per hour per bottle per minute, applies. It's a good rule of thumb and one to remember for sure. Now, depending on that machine type, as I mentioned, there will be either 2 or maybe 3 flushes of the bottle before it's filled. And another way of calculating a nitrogen flow, and check the manual, by the way, check the manual on the machine. It should tell you exactly how much nitrogen is needed. But we know what the size of a standard wine bottle is. We know it's 750 mils, which is 0.0265 cubic feet. So we can combine that volume with the speed and get an estimate on nitrogen consumption there. And you can see some examples here of a 2 flush and a 3 flush. The flow rates are not particularly high. You can see it's easily met by a nitrogen generator, but that's a discussion to have with the customer. How fast does your machine run? How many bottles per minute? And is it a 2 flush or a 3 flush? And it's really easy to get to that detail with the customer, and they'll know it. They'll know it inside out. Now, when it comes to nitrogen purity for wineries, 99.5 is all that's needed. So nitrogen with a residual oxygen level of 0.5%. That's perfect for winery. We've got hundreds and hundreds, literally hundreds of wineries operating at 99.5% purity. When wine is processed and protected and bottled with nitrogen at that level, you typically find the dissolved oxygen level, which is something wineries are looking at, less than 0.2 ppm. That's what a customer is going to be interested in, the dissolved oxygen level. And it's important not to, don't confuse the oxygen level, the dissolved oxygen level, with the oxygen level in the nitrogen stream. Sometimes I've seen people get mixed up with that and ask for nitrogen purity with 0.2 ppm. That's the dissolved level, not the level in the gas. Here's another installation here. This is a very high-end California winery using a nitrogen generator for their premium wines. And prices of $350 upwards per bottle are not unusual for this particular manufacturer. But regardless of that price, 99.5 protects their wine and keeps it in the exact condition that they want. I've not tried a $350 bottle myself yet. Some wineries that you come across will prefer to install nitrogen generators outside. Again, this is another one in California where they put a couple of nitrogen systems outside. We can do that. It's not preferable, but it's possible. You can see the system we provided here. We always prefer to have the generator protected from direct sunlight and a roof over the top with protect against rain too. But just to let you know, that is an option. It's something we've done with a bunch of wineries. It's not typical, but it is possible. Now, in addition to sharing some applications for tank blanketing and bottling and pressure transfer, there are a few things that are specific to breweries, craft breweries and microbreweries, that it's worth considering separately because the needs are quite different. But just the same as wine, though, the presence of oxygen is a big enemy to beer. Once that fermentation process starts, a brewer's main focus is just protecting that beer against oxidation. You can see in this picture, the beer on the right, that beer has been spoiled by oxidation. The batch has been wasted. So all that time and potentially thousands of dollars is wasted. That beer has to be thrown out. Beer spoiled by oxidation, as I've been reading, has been described as smelling and tasting like wet cardboard, which is obviously not how you want your beer to taste. So a lot of work is done by the brewers at all stages of that process to prevent the risk of oxygen spoiling that beer. Now, CO2 has been used in breweries for many years, provided in cylinders or dewars, sometimes in bulk tanks for the larger brewers. But CO2 is used to carbonate the beer to make it fizzy. So because a brewery needs that CO2 on site anyway, they've used it for purging. It's good for blanketing in tanks too, because being heavier than air, the CO2 forms a blanket on top of the liquid and it just settles there. So it's a good barrier for oxygen. So it's been used for many years. Now, in smaller breweries, you'll usually find CO2 is supplied in the dewars that are wheeled around the place, blanketing tanks, and then just replaced. But in recent times, we've actually come across a lot of instances where smaller brewers have been struggling to get delivery of CO2. CO2 has been prioritized for other applications, such as transporting medical devices, and it's just been very difficult for CO2 to be supplied to a brewer. And that's been leading brewers to contact people like Parker to discuss the opportunity of, can we replace CO2 with nitrogen? And there are some applications that you can. So although that CO2 is going to be on site anyway for carbonating that beer, there are some areas where nitrogen can be used instead of CO2 in a brewery. Purging is key, just as we described with wine. So brewing kettles, fermenting tanks, bright tanks, all purged with CO2 can be purged with nitrogen. The gases behave differently. It's not a one-for-one, cubic foot for cubic foot switch out. Nitrogen is so close to air that it diffuses and mixes with air, whereas CO2 being heavier settles. So the actual purging process is slightly different. And we can have a complete different session about that system alone. But it's worth bearing in mind and talking to a customer about, all right, reduce your CO2 consumption. Start purging with nitrogen. It can reduce their CO2 consumption, and it can change some of the processes. So we're not talking about completely replacing the CO2, but reducing the consumption. And a lot of customers can reduce their CO2 by 50, 60% easily, just by converting some of their applications to nitrogen from CO2. Now, here's a chart I've used a few times in various presentations that we've done. The Federal Reserve and the US Department of Labor statistics websites, they track a lot of industrial indices. And one of them is the industrial gas manufacturing prices of various gases. And one of them happens to be CO2. So here's the chart for the CO2 index right now. The last data was issued in February, so it's right up to date. And you can see, compared to January 2020, you can see the price, how the price has changed to the point where, as of February 2024, customers are paying almost 55% more for their CO2 from a gas company. So this is a good chart to show a customer. We do highlight this to a customer because they're feeling that pain. Their prices are going up. They can't control those prices. The gas companies will just put those prices up. So it's always worth asking a customer, how's your experience with your CO2 pricing been recently? The chances are they've experienced some price increases, and they'd be more open to switching out some of their CO2 to nitrogen. It'll save them money, make them more flexible without having to rely on outside deliveries. Now, at breweries in the US, there's a number of different keg sizes to suit different purposes and locations. You've got small home brewers, you've got smaller bars, you've got very large bars, you've got the enormous breweries. All of them use kegs for transporting beer. Now, the most important or the most popular size of keg is the half keg, or half gallon keg rather. And it's a volume of 15.5 gallons, about 165 cans of beer or 124 pints. You'll come across that size a lot. Now, nitrogen can be used for filling these kegs. So before the beer goes into the keg, that keg is first washed and sterilized, and then nitrogen is fed into that keg to pressurize it, and it's fed to about 30 psi. The beer is then transferred in under pressure, and the beer then has pressurized nitrogen, sometimes CO2, nitrogen on top, and that pressure that's in there helps push that beer from the keg up to the bar where it's dispensed. Now, one advantage of nitrogen like this is nitrogen will not dissolve into the beer. So the gas that's in there under pressure will not dissolve into the beer. If it was CO2 under pressure is more easily absorbed into the beer. So CO2, you could get some overcarbonation. Nitrogen would not do that. Now, if we have that standard most popular barrel, the half barrel keg, as an example, with a volume of 15.5 gallons, it takes about 6 cubic feet of nitrogen to pressurize it to 30 psi. Each machine will vary, but if you take about 30 seconds to fill it, you're looking at around 12 CFM. So that's an easy thing to do with a customer. Is like, all right, how many kegs are you filling per hour? How quickly do you fill it? Sometimes the beer is filled over a 10-minute period. Sometimes they're filled much faster. And it's a question of how many kegs do you fill per hour? Is your keg filling done every day? The smaller breweries might not be filling a keg every day. They might not be doing their kegging. They might do that 2 or 3 times a week. So do you have multiple machines? Do you have multiple lines? It's good practice to sometimes just pair a nitrogen generator with a storage tank. So there's always a stored volume available to dispense into this machine, fill the kegs, and then the generator just catches up in the downtime between filling. So talk to the customer about the working pattern. Now, when you go to larger breweries, even larger craft breweries, you will come across automatic wash and fill lines like this one. These machines will definitely have a flow and a pressure requirement for the nitrogen supply. So check the manual, check the rating plate. Sometimes the manufacturer's website is a good place to start too. This particular customer that I visited, they had a machine that fills 60 kegs per hour, and it needed 635 SCFH. Nitrogen was at about 87 psi. It was a perfect fit for a nitrogen generator, and it runs virtually every day. So this was an expensive piece of equipment. It was probably $300,000, but it was a great investment for that customer. Now, while some applications, such as vessel purging, nitrogen is a straight swap, CO2 out, nitrogen can go in because it's just a volume. Sometimes it's not so straightforward. Beer canning is one of those. If you visit a customer and they've got a beer canning line, if they are a significant volume, they'll be using an automatic line like this one. Now, if a customer's using this line, they'll be using it with CO2. Now, on beer canning lines, CO2 is always there because it carbonates the beer. It makes it fizzy and it fills under pressure. It's what's called filler bowl pressure. So CO2 is used there. Nitrogen can't be used there. But the can seamer And the bubble breaker just minimizes the foam on the beer before the can is sealed. Those things, those applications within that machine can be done with nitrogen, because all you're doing is purging out oxygen to prevent oxidation. So nitrogen can be used then. But in these cases, some re-engineering will be needed on the machine gas manifolds. And that's worth talking to a customer about, because it's not a straight swap when it comes to a canning line. It is possible, and we do have customers doing it with nitrogen. You also might find a customer who will use a blend of nitrogen and CO2 in the filler bowl, and then some who will stick purely with CO2. So switching part of that operation of that machine to nitrogen, it might need some modification. It might need a little bit of investment and a little bit of experimentation. It's possible, and it can significantly reduce the CO2 consumption, but that's something to be aware of. Now, gas supply options for breweries are no different to any other industrial customer. And you've got your cylinders, you've got your dewars, you've got potentially bulk liquid for the larger user. Most of what you will find, or most of what I find at smaller brewers, tends to be in dewars, occasionally cylinders, but mainly dewars, and the occasional bulk liquid user. And the questions that we always ask is, all right, if they're using cylinders, how long does your cylinder pack last you? Does it last one shift? Does it last X number of tank purges? Does it last X number of days? We know how much gas is in a cylinder pack. We know how many bottles are in there, either 12 or 16. We know the pressures. And we can easily just divide one by the other. But that's a conversation that you have to have with a customer. If you're using cylinders, how long do they last you? How long do you keep one online? How long till it's empty, till you need to replace it? It's a very straightforward discussion. And it's similar with dewars. Find out what size the dewar is. It's usually in liters of liquid nitrogen. So find out how big that dewar is. You can convert that liquid nitrogen to gas. We know that if it's in liters or in gallons. And then say, all right, how long does that dewar last you? Does it last you a day? Are you purging all of your tanks and it lasts you 4 hours? Divide the volume of gas in there by the time, and you get a good idea on the flow rate. It's a very straightforward thing. And then similarly, when you go up to bulk, it's the same thing. It's like, how big is your tank? How often do you get it filled? Sometimes you can get copies of invoices. Customer might not want to tell you exactly how much they're paying for their nitrogen, but sometimes they can give you invoices without a dollar value on them. I had one just this week give me 12 months worth of deliveries, and we were able to put a chart together and come up with a good idea on their flow rate. But again, it's just have that straightforward conversation with the customer. How big's your tank? How often do you get it delivered? Can we see some details on your average consumption? And then we can work out the flow rate there. It's very straightforward. So overall, nitrogen generators are becoming a really good option for smaller craft brewers and wineries of any size. And you get a good return on investment. These customers tend to be using dewars and cylinders. They tend to be using the more expensive way of getting nitrogen, so you get a good ROI against them. These customers like to be self-sufficient. The delivery problems that have been had in recent years on CO2 in particular is leading a lot of brewery companies to look at nitrogen generators as an option. It's just brewers want to be self-sufficient. They don't want to risk the beer that they've worked so hard to create to have to throw it out if they don't get CO2. So they like the flexibility. They like the fact that it's a convenient system to make their own nitrogen. Brewers do talk to each other a lot. Wineries less so, but brewers are more than happy to talk to each other about best practices, what they found works, what they found doesn't work. We've had a lot of instances where we've put potential customers in touch with existing customers, let them talk to each other about their experience. It's a good thing. The brewing community is very close, very close. Another thing that smaller brewers tend to like is reducing their carbon footprint. Every cubic foot of nitrogen that they use instead of using CO2 reduces their carbon footprint. And that's often a good motivation for a customer to consider a nitrogen generator. We do minimize the dissolved oxygen. The DO pickup is very low using nitrogen, and it just protects that beverage. And overall, a nitrogen generator can be a good customer experience. They can give a brewery or a winery control without relaxing any of their quality standards. So we find a lot of these applications are coming along.